times 4y cubed. I'm sorry about that, guys. Anyways, so this term will multiply that 3 times 4 gives us 12 x y cubed dy over dx
for the most part usually is an
plus
explicit
15
and what that
y
means is
times dy over dx equals, and now I subtracted the 8x and the 3y to the fourth to the other side, so I'll get minus 8x minus 3y to the fourth power. Now again, same thing as the last problem. I'm going to factor out that dy over dx, and we'll have dy over dx times 12x y cubed plus 15y equals negative 8x minus 3y the fourth power. Then we'll divide, and we'll get dy 12xy cubed plus 15y. And that is our final answer. I'm going to give you guys a second to plug that, or to copy that down while I plug in my tablet because it's running out of battery.
Here we can do the power rule, we can take the derivative. So, dy dx equals negative x to the negative second power, or negative 1 over x squared.
Minus x squared, so that we can get rid of that fraction. And that will let us avoid doing chain rule. So this is still going to be my original, my OG. And that's going to be, on the left side, 2x minus 5y squared. Right, those canceled. Equals negative x times 4y cubed out. So still the original. We have 2x minus 5y squared equals negative 4xy cubed. Negative times a negative plus x cubed. And now we're ready to find the derivative. So now we can take the derivative of this. I'll do that in a new color when we do it in green. The derivative of 2x is 2 minus the derivative of 5y squared is 10y times dy over dx equals, now with this, again, we're going to have to do a product rule. So the derivative of the first part, negative 4x, is negative 4y cubed. Again, since I took the derivative of the x term, I do not need to multiply by dy over dx. Then we'll do minus. Now we leave the 4x alone. We're going to multiply this by 3y squared. And this time, since I did do the derivative of the y, I need to multiply by dy over dx. Finally, plus, okay. So now you might be thinking, okay, we need to move over the dy over dx to this. I'm going to plug in for y, I'm plugging in 1, and for x we'll also plug in 1 because it was at the point, remember, 1 comma 1. So 10 times 1 times dy over dx equals negative 4 times 1 cubed minus 4 times 1 times 3 times 1 squared times dy over dx plus 3 times another 1 squared.
And it's the derivative of y with respect to x.
That will give us 2 minus 10 dy over dx.
So that would be
equals negative 4 minus 4 times 3 is 12, so I'll put minus 12
because we're taking it with
dy over dx plus 3.
Just a quick side.
Get this right.
If we did decide to do
the
derivative with respect to y, which you can do,
I am now going to solve for dy over dx. So again, I want to solve for this dy over dx. It's in two places. I need to get it to the same side. So I'm going to add 12 dy over dx to both sides. That'll cancel.
So it's 3y squared, and then you have to do the chain rule.
And while we're at it, we may as well subtract out this 2.
So that's kind of our difference.
And those will cancel. So we will end up with
then you have to do the
12 minus 10 is 2. dy over dx equals negative 6 plus 3, or 9.
That's the same thing.
Or no, that's not 9, huh? That's negative 6 plus 3 is negative 3. 2 times dy over dx equals negative dx equals negative 3 over 2. That is our final answer.
Of x plus 3.
Okay, so there's that. I'm going to have one more video that I'm going to post up, which is a super bonus. I kind of alluded to that earlier. You do not have to watch that last video. It's just an extra challenge problem. Kind of for those people who really want to push themselves and look at a really challenging problem that might be the difference between a 4 and a 5 on the AP test. So if you want to look at that last video, you can watch it later, or you can watch it now. If you don't want to watch it, don't at all feel like you need to. Alright guys, have a good weekend, and I will see you in class on Monday.
Multiplying those. So we're going to have to do a product rule. So, product rule, right? We take the derivative of the first term. So I'm taking the derivative of x, leaving y alone. So while I'm doing that part, the variables of what I'm doing the derivative of agree, right? So that's the derivative of x is just 1. I don't have to do chain rule, they agree. Y squared. Plus, now I leave the first term alone. So I leave x alone. And I take the derivative of the y squared term. This is where they don't agree, they're different. So the derivative is 2y, but we have to do chain rule because they don't agree. Dy dx. So that would be our derivative here. And then, if you want to factor anything, you can do that. Okay, so I want to do a couple examples with this. The first one's going to say find dy dx, right, the derivative, given that y cubed plus y squared minus 5y minus x squared equals negative 4. Now when we're doing the derivative, right, I'm going to rewrite this y cubed plus y squared minus 5y minus x squared equals negative 4. When we're doing the derivative, it's kind of like any operation in math. You add to both sides, right? You could add x squared to both sides, or you could multiply a number to both sides, or divide a number to both sides. It's kind of the same thing. So what you're going to do is you're going to take the derivative with respect to x of both sides. And this just goes to each term, right? We multiply it out, we expand it out to every single term. So it's going to be the derivative with respect to x of y cubed plus the derivative with respect to x of y squared minus the derivative with respect to x of 5y minus the derivative with respect to x of x squared equals the derivative with respect to x of 4, or negative 4, I guess. Now, in this case, alright, you don't really have to write this out every single time. You can just start doing it. So when you get good at this, you can just kind of skip writing everything I just wrote out in red. You just basically go straight to, okay, I know that the derivative of y cubed is 3y squared dy dx, because it's going to be that implicit chain rule. My variables are different. Plus 2y dy dx equals negative, minus 5 dy dx minus 2x equals, now the derivative with respect to of x of negative 4, it's a constant, so it's just going to equal 0. So just really quickly to review, derivative of y cubed is 3y squared, but we have to do the chain rule dy dx. Derivative of y squared is 2y, we have to chain rule it. Derivative of 5y is 5, but it was minus 5, and then we have to chain rule it. Derivative of x squared is 2x, right, minus 2x. The variables were the same, so we don't do the chain rule. And if you did, it would be dx dx, which divide anything by itself is just 1. And then derivative of any constant number is 0. So now I'm to this step in blue. And remember, we're solving for dy dx. So I have a dy dx here, here, and here. What we're going to do is we're just going to move everything that's not a dy dx over to the other side, and then we'll be able to factor it out. So right now the only term that doesn't have dy dx is this negative 2x, so we're going to add it to the other side, and we'll end up with 3y squared dy dx plus 2y dy dx minus 5 dy dx equals 2x. Now we see that we have dy dx everywhere, which means we can factor out that term dy dx. So we factor out a dy dx, we're left with 3y squared plus 2y minus 5 equals 2x. And then we'll divide both sides by 3y squared plus 2y minus 5. And that cancels, and we end up with dy dx equals 2x divided by 3y squared plus 2y minus 5. We're going to check, see if we can factor this at all, or if we can simplify anything. We can't, so that's going to be our answer right there. Sometimes a problem will ask you to do a little bit more. It'll ask you to plug in an x or plug in a y and get a value, but this is kind of the basic implicit. Okay, so that's going to kind of bring us to our next example, which is going to be finding the slope of an implicit function at a certain point. Now when we see this word slope, we're immediately going to think of derivative, which is dy dx. And at this point, 3, 1, that means x equals 3 and y equals 1. So first we're going to take the derivative, then we're going to plug in x is 3, y is 1. So I'm going to take the derivative of both sides with respect to x, and that gives me the derivative of x squared is 2x plus the derivative of 4y squared is going to be 8y, but these are different, so times dy dx equals, and the derivative of any constant number is just 0. Now we're going to solve for dy dx, so I'm going to subtract 2x to both sides, and that gives me 8y dy dx equals negative 2x. We'll divide both sides by 8y, because remember we're solving not for y but for dy dx. And that gives me dy dx equals, we can simplify that to negative x divided by 4y. Now, in the last problem, this would have been our answer right here. But this is the derivative. We want to have the slope of this line at the point 3, 1. So we're going to just plug in that x equals 3, so it's going to be dy dx equals negative 3 divided by 4 times 1, which is going to be equal to negative 3/4. Okay, last problem I want to do is just a problem with kind of chain rule in here. So I want us to just find what would be the derivative if we had something like 3x squared plus y squared squared. And so if we take the derivative with respect to x, we see this is our inside. This is a chain rule. So we bring the 2 down. That's 6. We leave everything inside alone. X squared plus y squared to the first power. Now we multiply by the derivative of the inside. I'm going to put a parenthesis here. The derivative of x squared is 2x, right? These are the same. Plus the derivative of y squared is 2y times dy dx. So that's just an example of if you had to do the derivative of something that would involve chain rule. You don't multiply by dy dx here. You only multiply once you actually take the derivative of something that directly has the y in it. Alright, that's it for the notes. I'll see you guys in class.